Hello everyone, welcome back to our channel Electro Study. This is lecture series 2 Embedded C Basics dealing with introduction about microcontroller. In the last video, we have seen about the microprocessor. In this video, we will be discussing about the microcontroller. So in microprocessor, we have seen that it is a small chip which is designed to perform some application. So the same goes for microcontroller. It is something very small. It is like a small chip. It is very low. It is a low cost computer on chip, and it performs any number of tasks given to it, but it performs only specific set of tasks. So this microcontroller, this you can take it as a block diagram of microcontroller, where you can understand what are the interfaces that is connected across the microcontroller. So you are having CPU, that is central processing unit, where all the processing of the data that is coming inside the microcontroller will be processed. This is the bus, where bus acts as an interface between your input and output interface. That is, your bus is something called as a communication channel, and you have memory input output ports. So you here in microcontroller you use RAM and ROM, and input output ports are available, and you have many input output ports: port 0, port 1, port 2, and port 3. And here you have interrupts and serial communication. Here you can tell that the microcontroller communicates in the form serially. There is parallel communication and serial communication. So serially the communication takes place, and interrupts is nothing but it is going to tell the or alert the microcontroller about the high priority and low priority task. You have timers and counters, where timers will be set to count the number of seconds or number of minutes that is taken for a particular task to complete. And counters is nothing but it keeps counting the number of cycles taking place for particular instruction to be executed. You have ADC and DAC, which is nothing but analog to digital and digital to analog converter. So there are some common examples of microcontroller like Arduino, Raspberry Pi, and PIC microcontroller. These are some very few examples that I have listed out. You have many number of examples that comes under microcontroller, and you will know that the microcontroller is programmed using some specialized computer language. So first it was using assembly level language, then it moved into C, then to embedded C. Now with Raspberry Pi, we are using Python as a language to communicate with Raspberry Pi. So the technology is moving on. And now coming to types of microcontroller, it is actually divided based on number of bits, memory, instruction set. So when you are taking instruction set, as we have seen in the other series, microprocessor also has two set of instruction set, that is RISC and CIS, that is reduced instruction set cycle and complex instruction set cycle. So these are the two instruction set. Based on what kind of architecture the microcontroller is, the instruction set is chosen accordingly. And memory is, you have external and embedded memory. So generally in microprocessor you don't have any memory, you are connecting it from external world. But in microcontroller you have embedded memory, you already have RAM and ROM. Other than that, if you need more space, you are allowed to connect any other external memory to the microcontroller. And based on the bits, 8 bits, 16 bits, 32 bits, 64 bits, based on the bits, the types of the microcontroller may differ. And you have an architecture, two kinds of architecture, whether it is microprocessor or controller, you have two architecture. One is Hardvard and von Neumann architecture. So hardware architecture is nothing but this architecture will have separate bus and separate storage devices for storing your instructions or data that is fed into. You will have separate storage system and separate bus. But when you have von Neumann architecture, here both the data and the program completely share the same memory. That is, I'll tell you, when a data like 0H, 03A is being transmitted from the input part, then it is stored in a particular memory, and the instruction like add, multiplication, division, all those will be stored in another memory. So when the data and the program are stored separately, then it is known as hardware, and if it is stored in the same memory space, then it is known as von Neumann. So when compared to these two architecture, we can tell that hardware architecture gives you much advantage because you have separate buses and the storage is separate. So obviously you will have high number of storage data and instructions that can be stored, and it can be read and write at the same time. So there are many advantages when compared to von Neumann, because von Neumann is only one single processor which is sharing the same memory. So if suppose if small error happens, then you cannot rectify it, you cannot use any other memory, so complete data and instruction sets will be spoiled. So based on the parameters, we will be seeing the difference between the microprocessor and the microcontroller. So you know what is the definition? Microprocessor is nothing but it is the heart of the computer system. It is the heart of the embedded system. So now only make sure that there is small difference where microprocessor is heart of the computer system. It is the heart of embedded system. So what is microprocessor? So it is nothing but it is a processor where the input, output and the memories are connected externally. There is no embedded memory or embedded input output ports. It is not so with microcontroller. You have all the memory devices, input output ports, everything attached internally. So how the circuit complexity will be? So when we are connecting all the input output memory externally, then it is complex. When it is embedded into the microcontroller, then the circuit complex is very less. Based on memory and input output components, it is connected externally where it is embedded into the microcontroller. Based on the capability, you can see that the microprocessor, it is not such compact devices. You cannot perform a number of applications because based on the bits and based on its own capability, because memory input output everything is connected externally, so the memory occupying will be very less. So all those are there. So it is not about it is not so with microcontroller. It is a compact system where you can perform any number of tasks, and efficiency will be when the system is not compact, obviously it will be less efficient than the microcontroller. And you will have status flag. I'll be explaining about you what is flag in the later series. And when you see about the application, you can see that the microprocessor are used in personal computers, wherein microcontrollers are used in washing machine, air conditioner, fridge, TV, many things that we use in the real time life. So hope you have understood about the microcontroller a bit. We'll be seeing one kind of microcontroller in the next lecture series. Please be stay tuned. Thank you.